Very good. So, can I just see a quick show of hands? Who's seen sine diagrams before? Excellent. A couple of us, very good. So it's going to start pretty easy. All right, we're going to start by drawing sine diagrams from a graph, and then we'll stop and we'll look at an algebraic process. So this will take about 5 minutes, and then we'll spend about 10 minutes going through question 1 of the textbook together. Hopefully pretty okay skill, and then question 2 is where it's going to start to get a bit harder. So all a sine diagram is an axis that indicates to you where a function is positive, that is where it is above the x-axis, and where it is negative, that is where it is below the x-axis. So what we're going to do is below the graph, we're going to draw a line with arrows pointing. This represents the x-axis, all right? And on the x-axis, we're going to plot the roots, okay? Now, we're going to use, for the rest of your career here at Tennyson, when we're talking about mathematics, we're going to use the words roots, zeros, factors as well if you're going to do spec, but roots and zeros, we're going to use those synonymously, all right? X-intercepts, that's what they mean, okay? It is where, x-intercepts, where does the function cross the x-axis? So if we look here, we can see it crosses at -3. So our very first thing is to put a -3 there on the sine diagram. Now we must draw a line, all right? We're not just drawing a dot, we must draw a line there because that shows that it's a root, that it crosses at that point. It equals 0 at that point. And then what we can see is to the left of -3, okay? In that region, the y values are positive. It is above the x-axis, it has positive y values. And in this region, it is negative. It's below the x-axis, it has negative values. You right, Gemma? That's it. That's the sine diagram. When's it positive, when's it negative? Let's move on to the next one. We're going to draw the axes. Okay, we're going to plot the roots on there. So we've got -4 here, and we've got +2 here. Okay, so we plot the roots. And then we go, where is it positive? Where is it negative? So we just work from left to right. You can see to the left of -4, it is below the x-axis. Below the x-axis, the y values are negative. All right, in between -4 and +2, the y values are above the x-axis, the y values are positive, and then negative. Okay. Now we're going to get a little bit trickier. We have to include all of the roots, even if it doesn't cross. So -3 is a root, and 5 is one of the other roots as well. And so what's going on here is it's positive, it's above the x-axis until it gets to -3, right? And then after -3, it is still above the x-axis. But we still need to include that point because the function is 0 at that point. At that point, the y value is 0. It's neither positive nor negative. So what we're doing is we're indicating at that point, the function is 0. And then we have this 5. After 5, it is negative. Okay, on to the next one. Now, here we've got some asymptotes. On a sine diagram, we always include any vertical asymptotes. So they're the asymptotes that go down. We don't include the ones that go horizontal, we only include the ones that go down. So we have a vertical asymptote, and the way we indicate that is by a dotted line on our sine diagram at -3. Okay, we're told the equation of that dotted line is x is -3. And we have a root, that is, it crosses the x-axis, the function crosses the x-axis at x is -2. All right, so we've got the roots and the asymptotes on the sine diagram, and then we're just going to look at the function. Okay, we can start from the left. Okay, to the left of the asymptote, the function is completely below the x-axis. Everywhere along here is below the x-axis. It is negative in that region. Between -3, so from the asymptote, to -2, the function is positive. It's above the x-axis in that region. And then after minus 2, it's below the x-axis, it is negative. Okay, last one. This is a pretty confusing function. This is the tangent function. So we'll learn about these a little bit later in the year, in the semester even. And all we're doing though is drawing the axes, and we're going to plot the asymptotes and the roots. Okay, the asymptotes where the dotted lines are, the roots where the function crosses the axes. So we have an asymptote at minus 6, we have an asymptote at minus 2, asymptote at positive 2, and an asymptote at positive 6. And then we have roots. We have a root at minus 4, a root at 0. All right, don't forget that one. That point there is 0. And a root at positive 4. Okay, so all I'm doing first, where's the asymptote? Putting that on my axes here. Where's the roots? Minus 4, 0, positive 4. Putting them on my axes here as well. Okay, and then it's just an indication, where is it positive, where is it negative. So before minus 4, between minus 4 and minus 6, it is above the x-axis, positive, negative, positive, negative. It's just going to follow that pattern for this function. Won't always follow the pattern, okay, but it does in this circumstance. You can see it's above, it's below, it's above, it's below, it's above, it's below. Very good. So that's enough to have a go at question 1. So let's shred that, and then we're going to look back up here at an algebraic process where it's a bit more complex.